When you picture a zombie, your mind probably jumps straight to some mindless creature, right? Brain totally scrambled by a virus. It's a classic for a reason. But what if I told you that the most sophisticated, most successful form of zombification on our planet has zero interest in your mind? We're about to get into a reality that is way, way stranger, and honestly, a lot more terrifying than any movie you've ever seen. See, the most successful parasite on Earth doesn't want to turn your brain to mush. Not at all. It wants to quarantine you. It wants to lock you inside your own skull, leaving you perfectly horribly aware while it takes your body for a joyride. And no, this is not science fiction. This is the very real, very established science of the fungus Cordyceps unilateralis. So here's the first big mistake we always make. Scientists actually have a name for it, the neurocentric fallacy. It's this idea that to control a body, you have to seize the command center first. The brain. But honestly, that's kind of clumsy. The zombie ant fungus has figured out a much more elegant and way more sinister strategy. So how in the world does it actually work? Well, the fungus pulls off something called a peripheral usurpation. That's a fancy way of saying it completely bypasses the pilot to manually operate the machinery. Think about it. It doesn't bother hacking the software. It installs its own hardware directly into the system. Let's break down exactly how this terrifying invasion happens. This invasion, it's a masterclass in bioengineering, and it happens in 3 stages. First, you've got the breach. A specialized part of the fungus acts like a high-pressure drill, using enzymes to literally melt its way through the ant's tough exoskeleton. Once it's in, it spreads as these little stealth cells, floating through the ant's blood like ghosts. But the final step, this is the truly terrifying part. It's called hyphal anastomosis. All those single fungal filaments start to fuse together, creating this seamless, interconnected biological circuit that completely encases the ant's muscles. And here's what's so wild about this. That fungal network, it doesn't just send signals, it is the signal. It forces the ant's muscles into what's called a hypercontractile state. It's physically overpowering the ant's own brain signals. It's so strong it can actually break the muscle's internal structures to lock its jaws in that famous death grip, all while the ant is still very much alive. Okay, to really get this, let's use an analogy. Imagine you're in one of those fancy self-driving cars. You're just cruising. Suddenly, someone hijacks it. But here's the thing. They don't touch the car's computer at all. Instead, they've somehow attached powerful hydraulic pistons directly to the wheels. You are wide awake, you are screaming, you are slamming your foot on the brake pedal, yanking the wheel, but the car isn't listening because it's being physically forced to move. That is exactly what's happening to this ant. And this right here brings us to the most mind-bending, bone-chilling part of this whole thing. The fungus doesn't just ignore the brain, it goes way out of its way to actively protect it. And that creates this horrifying paradox, a completely conscious prisoner trapped inside its own body. So you have to ask the question, right? It's the central mystery here. If you've built this incredible system that completely bypasses the driver, why on earth would you waste energy keeping that driver not just alive, but in perfect working condition? Why not just shut the brain down? Well, the answer, it turns out, is chemistry. Researchers discovered that the ant's head is flooded with a special compound called ergothioneine. It's the super powerful antioxidant that the fungus itself makes. It's not a poison, it's a preservative. The fungus is literally embalming the ant's brain while it's still alive, meticulously making sure none of the neurons die. And why would it do that? Because the fungus is blind. It has no eyes, no ears, no way to sense the world around it. It needs the ant's sensory equipment. It needs the pilot to read the instruments. It keeps the ant's mind online to navigate to the perfect spot, the one with the exact right amount of light and humidity that the fungus needs to sprout from its head and reproduce. The ant's consciousness is just another tool. Okay, so what we've just covered is a horror story on a microscopic scale. But now I need you to zoom out with me. I mean, way, way out. Because this whole thing isn't just about one poor ant. This is about a hidden intelligence that spans the entire globe. So a global analysis just last year came up with this staggering number. The total length of fungal mycelium just in the top few inches of Earth's soil is estimated to be 450 quadrillion kilometers. That's a number so huge it barely makes sense. To try and put that in perspective, if you could unravel it all, it would stretch about halfway across our own Milky Way galaxy. And what that means is the ground beneath our feet is just unbelievably dense with this stuff. We're not just walking on dirt, we're walking on a planetary-scale biological circuit board. Get this. Every single time your foot hits the ground, you are pressing down on roughly 300 miles of this living, active network. But here's the catch. This intelligence, it operates on a completely different timescale. A signal in one of your neurons zips along at about 100 meters per second. A signal in this fungal network, it moves about 200,000 times slower. This network isn't silent, it's just thinking in deep time. Just look at this comparison for a second. Our brain is like this centralized command center, right? The fungal network is completely distributed, a scale-free system. And the sheer length of it, it just dwarfs our own neural network. The key difference here isn't whether or not there's intelligence, it's the architecture and the speed. So, what does all this mean for us, for how we understand ourselves? Because this whole zombie ant story, it forces us to ask some really uncomfortable questions about consciousness, about free will, and about what it even means to be an individual. What the ant shows us, unequivocally, is that your awareness can be totally separate from your control. You can be home, but someone else is driving. And if you scale that idea up, you really have to start wondering, are we living inside a planetary-scale computer, a kind of biological internet? In that model, the fungal network is the motherboard. The trees are its peripherals, its solar panels and sugar factories. And animals? Well, we might just be the delivery drones. And that really leaves us with one final, deeply unsettling thought. The real horror of the zombie ant isn't that it loses its mind. The horror is that it doesn't. It just becomes a passenger. So if your body were hijacked tomorrow, if your actions were just subtly guided by an intelligence so slow you couldn't even perceive it, would you know? Or would you just invent reasons for your new behaviors, watching helplessly from the glass cockpit of your own skull?